the installation described presents multiple safety concerns that require attention. Firstly, exposed extension cords present a significant hazard. The use of an orange extension cord and a dryer cord to power the pumps, with both being exposed over considerable distances, creates both a tripping hazard and a potential for electrical shock. Secondly, the cord caps on both of these extension cords appear to be field installed. Field installed cord caps might not meet electrical code requirements, and this could result in loose connections or overheating. Thirdly, the lack of grounding is a crucial issue. It appears that the extension cords lack proper grounding. This increases the risk of electrical shock should a fault occur in the system. Fourthly, there is the use of polyvinyl chloride, Schedule 80, conduit for electrical wiring. Polyvinyl chloride, Schedule 80, conduit is not approved for routing electrical wires. Polyvinyl chloride is not recognized as an appropriate electrical conduit material. It cannot provide the required protection from moisture or mechanical damage. Fifthly, the installation has multiple code violations. The described installation violates established electrical codes, including the National Electrical Code, otherwise known as NEC, and local ordinances. These codes mandate proper grounding, protected wiring, and the use of approved electrical materials. To ensure safety and compliance with regulations, several actions are necessary. Firstly, install proper wiring. Replace the extension cords with permanent wiring routed through approved electrical conduit or armored cable. This will provide a safe and durable electrical connection. Secondly, use approved cord caps. Install cord caps that are specifically designed for the wire type and voltage being used. This ensures a secure and compliant connection. Thirdly, provide grounding. Ensure that all electrical equipment is properly grounded. This will prevent electrical shock in the event of a fault. Fourthly, use suitable conduit. If conduit is necessary, use approved electrical conduit designed to protect and support electrical wires. This will provide adequate protection and support for the wiring. Fifthly, have the installation inspected. Contact a qualified electrician to inspect the installation and ensure that it meets all electrical and plumbing codes. This will help identify any potential hazards and ensure compliance with regulations. Electrical safety is a critical aspect of any installation involving electrical equipment, and it is crucial to address these hazards to protect individuals and property. Improper wiring, lack of grounding, and the use of non-approved materials can lead to serious electrical shocks, fires, and other safety hazards. By following the recommendations outlined, you can ensure that the installation is safe, compliant, and reliable. In addition to the above-mentioned points, it is also important to consider the following factors. Firstly, overload protection. Ensure that the electrical circuit is properly protected with circuit breakers or fuses of the appropriate rating to prevent overloading the circuit and causing a fire. Secondly, weatherproof enclosures. Use weatherproof enclosures for all electrical connections and equipment located outdoors to protect them from moisture and corrosion. Thirdly, regular maintenance. Perform regular maintenance on the electrical equipment to ensure that it is in good working condition and that there are no loose connections, damaged wires, or other potential hazards. Fourthly, safety training. Provide safety training to all personnel who work on or around electrical equipment to ensure that they are aware of the potential hazards and how to avoid them. Fifthly, emergency procedures. Develop and implement emergency procedures to be followed in the event of an electrical accident or fire. These procedures should include instructions on how to shut off the power, evacuate the area, and call for help. Sixthly, labeling and signage. Label all electrical equipment and wiring with appropriate warnings and instructions to prevent accidental contact or misuse. Seventhly, arc flash protection. Evaluate the risk of arc flash and provide appropriate personal protective equipment to workers who may be exposed to this hazard. Eighthly, surge protection. Install surge protection devices to protect electrical equipment from damage caused by voltage surges or spikes. Ninthly, bonding. Bond all metal parts of the electrical system together to create a low impedance path for fault current and prevent electrical shock. Tenthly, inspection and testing. Conduct regular inspections and testing of the electrical system to identify and correct any potential hazards. The National Electrical Code (NEC) provides comprehensive guidelines for electrical safety and should be followed at all times. It is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. Compliance with the NEC helps ensure that electrical installations are safe for people and property. Several key articles and sections of the NEC are relevant to the safe installation and operation of electrical systems. Article 110 covers the general requirements for electrical installations, including the quality and approval of equipment, wiring methods, and workmanship. It emphasizes the importance of using listed or labeled equipment that has been evaluated by a recognized testing laboratory. Article 210 addresses branch circuits, which are the circuits that supply power to outlets, lighting, and other equipment. It specifies the types of wiring methods that are permitted, the size of conductors, and the overcurrent protection requirements. Article 250 covers grounding and bonding, which are essential for protecting against electrical shock and fire hazards. It outlines the requirements for grounding electrodes, grounding conductors, and equipment bonding jumpers. Article 300 contains the general requirements for wiring methods, including the installation of cables, raceways, and other wiring systems. It specifies the types of wiring methods that are permitted in different locations and the requirements for supporting and protecting wiring. Article 310 addresses conductors for general wiring, including the ampacity of conductors, the types of insulation, and the requirements for directing conductors when they are installed in close proximity to each other. Article 400 covers flexible cords and cables, which are often used to connect portable equipment to power sources. It specifies the types of cords that are permitted, the ampacity of the cords, and the requirements for strain relief and protection. Article 430 addresses motors, motor circuits, and motor controllers. It outlines the requirements for motor protection, motor disconnecting means, and motor control circuits. Article 500 covers hazardous locations, which are areas where flammable gases, vapors, or dust may be present. It specifies the types of equipment and wiring methods that are permitted in these locations. Article 600 addresses electric signs and outline lighting. It outlines the requirements for sign circuits, sign supports, and sign grounding. Article 700 covers emergency systems, which are systems that provide power to essential loads during a power outage. It specifies the requirements for emergency power sources, emergency lighting, and emergency circuits. Article 701 addresses legally required standby systems, which are systems that provide power to critical loads that are required by law to be operational during a power outage. It specifies the requirements for standby power sources, standby lighting, and standby circuits. Article 702 covers optional standby systems, which are systems that provide power to non-essential loads during a power outage. It specifies the requirements for standby power sources, standby lighting, and standby circuits. Compliance with the NEC is essential for ensuring the safety of electrical installations. By following the NEC guidelines, electrical contractors and installers can minimize the risk of electrical shock, fire, and other hazards. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. It is important to check with the local authorities to determine the specific requirements for electrical installations in your area. Electrical safety is a shared responsibility. Everyone who works on or around electrical equipment should be trained in electrical safety procedures and should follow all applicable safety regulations. By working together, we can create a safer environment for everyone. When selecting electrical equipment, be sure to choose products that are listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, otherwise known as UL, or Electrical Testing Laboratories, otherwise known as ETL. Listed or labeled equipment has been tested and found to meet established safety standards. When installing electrical wiring, be sure to follow all applicable codes and regulations. Use the correct wiring methods, conductor sizes, and overcurrent protection devices. When working on electrical equipment, always energize the circuit before starting work. Use lockout/tagout procedures to prevent accidental energization of the circuit. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Inspect electrical equipment regularly for damage or wear. Replace any damaged or worn equipment immediately. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use extension cords sparingly. If you must use an extension cord, choose a cord that is the correct size for the appliance or equipment you are using. Do not run extension cords under rugs or furniture, where they can be damaged. Keep electrical equipment away from water. Water can conduct electricity and cause an electrical shock. Teach children about electrical safety. Show them how to use electrical appliances safely and warn them about the dangers of playing with electricity. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. An electrician has the training and experience to safely install and repair electrical equipment. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can protect yourself and your family from electrical hazards. The use of extension cords in permanent wiring applications is generally not recommended or permitted by electrical codes. Extension cords are designed for temporary use and are not intended to be used as a substitute for permanent wiring. The National Electrical Code, NEC, specifically prohibits the use of extension cords as a substitute for permanent wiring in Section 400.8. This section states that flexible cords and cables shall be used only for pendants, wiring of luminaires, portable and mobile signs, connection of portable appliances, connection of moving pots, temporary wiring, and other applications as permitted or required elsewhere in the code. Extension cords are not designed to withstand the same level of wear and tear as permanent wiring. They are more susceptible to damage from abrasion, moisture, and other environmental factors. This damage can lead to electrical shock, fire, and other hazards. Extension cords are typically not grounded. This lack of grounding increases the risk of electrical shock if there is a fault in the electrical system. Extension cords can be easily overloaded. Overloading an extension cord can cause the wires to overheat and start a fire. Extension cords can be a tripping hazard. Running extension cords across walkways or other areas where people walk can create a tripping hazard. If you need to extend an electrical circuit, it is always best to install permanent wiring. Permanent wiring is designed to be safe and reliable. It is also more aesthetically pleasing than extension cords. If you must use an extension cord, use it safely. Choose a cord that is the correct size for the appliance or equipment you are using. Do not overload the cord. Do not run the cord under rugs or furniture. Keep the cord away from water. Inspect the cord regularly for damage. Replace any damaged cords immediately. The use of polyvinyl chloride, Schedule 80, conduit for electrical wiring is generally not recommended or permitted by electrical codes. Polyvinyl chloride, Schedule 80, conduit is a type of plastic conduit that is commonly used for plumbing applications. However, it is not designed to be used for electrical wiring. The National Electrical Code, NEC, specifies the types of conduit that are permitted for use with electrical wiring in Chapter 3. This chapter lists several types of metal and non-metallic conduit, but polyvinyl chloride, Schedule 80, conduit is not one of them. Polyvinyl chloride, Schedule 80, conduit is not strong enough to protect electrical wiring from physical damage. Electrical wiring can be damaged by impact, abrasion, and other physical forces. This damage can lead to electrical shock, fire, and other hazards. Polyvinyl chloride, Schedule 80, conduit is not resistant to heat. Electrical wiring can generate heat, especially when it is carrying a large current. This heat can cause the polyvinyl chloride, Schedule 80, conduit to melt or deform, which can damage the wiring. Polyvinyl chloride, Schedule 80, conduit is not grounded. Grounding is essential for protecting against electrical shock. If there is a fault in the electrical system, the grounding system provides a path for the fault current to flow back to the source. This causes the circuit breaker to trip, which de-energizes the circuit and prevents electrical shock. If you need to protect electrical wiring from physical damage, use a type of conduit that is specifically designed for that purpose. Some common types of electrical conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. These types of conduit are all strong, durable, and resistant to heat. They are also grounded, which provides protection against electrical shock. In addition to using the correct type of conduit, it is also important to install the conduit properly. The conduit should be supported properly and should be installed in accordance with all applicable codes and regulations. If you are not familiar with electrical wiring, it is best to hire a qualified electrician to do the work. An electrician has the training and experience to safely install electrical wiring and conduit. When selecting electrical equipment, it is important to choose products that are listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, otherwise known as UL, or Electrical Testing Laboratories, otherwise known as ETL. Listed or labeled equipment has been tested and found to meet established safety standards. When installing electrical wiring, be sure to follow all applicable codes and regulations. Use the correct wiring methods, conductor sizes, and overcurrent protection devices. When working on electrical equipment, always de-energize the circuit before starting work. Use lockout/tagout procedures to prevent accidental energization of the circuit. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Inspect electrical equipment regularly for damage or wear. Replace any damaged or worn equipment immediately. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use extension cords sparingly. If you must use an extension cord, choose a cord that is the correct size for the appliance or equipment you are using. Do not run extension cords under rugs or furniture, where they can be damaged. Keep electrical equipment away from water. Water can conduct electricity and cause an electrical shock. Teach children about electrical safety. Show them how to use electrical appliances safely and warn them about the dangers of playing with electricity. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. An electrician has the training and experience to safely install and repair electrical equipment. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can protect yourself and your family from electrical hazards. Ensuring proper grounding in electrical systems is paramount for safety and code compliance. Grounding creates a low impedance path for fault current to return to the source, tripping the overcurrent protection device, like a circuit breaker or fuse, and quickly de-energizing the circuit. This prevents dangerous voltage build-up on metal parts, reducing the risk of electric shock. Grounding also helps stabilize voltage levels, minimizing electrical noise and interference that can disrupt sensitive electronic equipment. The National Electrical Code, NEC, outlines comprehensive requirements for grounding and bonding in Article 250. These requirements cover various aspects of grounding, including grounding electrode systems, grounding conductors, and equipment bonding. A grounding electrode system typically consists of one or more grounding electrodes connected to the earth. Common grounding electrodes include metal underground water pipes, ground rods, and ground plates. The grounding electrode system must have a resistance to ground of 25 ohms or less. Grounding conductors are used to connect the grounding electrode system to the electrical system. Grounding conductors must be sized according to the requirements in NEC Table 250.122. Equipment bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault current. Equipment bonding is typically achieved using bonding jumpers, which are conductors that connect metal enclosures, raceways, and other metal parts. In addition to the NEC requirements, local jurisdictions may have their own grounding requirements. It is important to check with the local authorities to determine the specific grounding requirements for your area. When installing a grounding system, it is important to follow all applicable codes and regulations. Use the correct grounding methods, conductor sizes, and bonding techniques. Inspect the grounding system regularly for damage or wear. Replace any damaged or worn components immediately. Do not disconnect or remove any part of the grounding system. If you are not familiar with electrical grounding, it is best to hire a qualified electrician to do the work. An electrician has the training and experience to safely install and maintain grounding systems. The proper selection and installation of cord caps are essential for electrical safety and compliance with electrical codes. Cord caps, also known as attachment plugs, are the devices that connect flexible cords to electrical outlets or equipment. They provide a safe and reliable means of transferring electrical power. The National Electrical Code, NEC, provides specific requirements for cord caps in Article 400. These requirements cover various aspects of cord caps, including their construction, rating, and installation. Cord caps must be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, otherwise known as UL, or Electrical Testing Laboratories, otherwise known as ETL. This listing ensures that the cord cap has been tested and found to meet established safety standards. Cord caps must be rated for the voltage and current of the circuit to which they are connected. The voltage rating of the cord cap must be equal to or greater than the voltage of the circuit. The current rating of the cord cap must be equal to or greater than the current drawn by the equipment connected to the cord. Cord caps must be properly installed. The wires must be securely connected to the terminals of the cord cap. The cord grip must be tightened to prevent the cord from being pulled out of the cord cap. The cord cap must be protected from moisture and physical damage. When selecting a cord cap, choose a cord cap that is appropriate for the application. Consider the voltage, current, and environment in which the cord cap will be used. When installing a cord cap, follow the manufacturer's instructions. Use the correct tools and techniques. Do not over-tighten the screws or terminals. Inspect cord caps regularly for damage or wear. Replace any damaged or worn cord caps immediately. Do not use cord caps that are cracked, broken, or otherwise damaged. If you are not familiar with electrical wiring, it is best to hire a qualified electrician to do the work. An electrician has the training and experience to safely install cord caps. The installation you describe involves both electrical and plumbing components, creating a situation where both electrical and plumbing codes and best practices must be considered. From an electrical perspective, the use of extension cords as permanent wiring is a significant violation of the National Electrical Code, NEC. Extension cords are designed for temporary use and are not rated for continuous operation or the environmental conditions they may be exposed to in a permanent installation. This can lead to overheating, insulation breakdown, and increased risk of fire or electrical shock. The NEC requires that all permanent wiring be installed in approved raceways, such as electrical metallic tubing, otherwise known as EMT, rigid metal conduit, otherwise known as RMC, or non-metallic conduit, such as rigid polyvinyl chloride, otherwise known as rigid polyvinyl chloride conduit, for protection against physical damage and environmental factors. The use of Schedule 80 polyvinyl chloride conduit for electrical wiring is also a concern. While Schedule 80 polyvinyl chloride conduit is permitted for some underground applications, it is not suitable for all wiring methods. The specific requirements for conduit type and installation depend on the location, environment, and type of wiring being used. It is crucial to consult the NEC and local codes to ensure that the appropriate conduit is selected and installed correctly. Grounding is another critical aspect of electrical safety. All electrical equipment must be properly grounded to provide a path for fault current to return to the source, minimizing the risk of electrical shock. The use of extension cords without a grounding conductor or with improper grounding connections can create a dangerous situation. The NEC requires that all grounding connections be made in accordance with specific requirements, including the use of approved grounding connectors and proper bonding techniques. From a plumbing perspective, the installation of water pumps and related equipment must comply with the Uniform Plumbing Code (UPC) or the International Plumbing Code (IC), depending on the local jurisdiction. These codes address various aspects of plumbing systems, including water supply, drainage, and venting. The installation of water pumps must comply with the requirements for pump sizing, piping materials, and backflow prevention. Backflow prevention devices are essential to protect the potable water supply from contamination. The plumbing codes also address the installation of water softeners, including requirements for drain connections and backwash disposal. In addition to the electrical and plumbing codes, the installation must also comply with all applicable building codes and regulations. These codes address various aspects of building construction, including structural integrity, fire safety, and accessibility. It is essential to obtain the necessary permits and inspections to ensure that the installation complies with all applicable codes and regulations. To address the safety concerns and code violations identified, the following actions should be taken. Firstly, remove all extension cords and install permanent wiring in accordance with the NEC. Use approved raceways and wiring methods to protect the wiring and ensure its long-term reliability. Secondly, ensure that all electrical equipment is properly grounded. Install grounding conductors and bonding jumpers in accordance with the NEC requirements. Thirdly, verify that the plumbing installation complies with the applicable plumbing codes. Ensure that the water pumps are properly sized, piped, and protected against backflow. Fourthly, obtain the necessary permits and inspections from the local authorities. This will ensure that the installation complies with all applicable codes and regulations. Fifthly, hire qualified professionals to perform the electrical and plumbing work. Ensure that the electricians and plumbers are licensed and experienced in the type of work being performed. By taking these actions, you can ensure that the installation is safe, code compliant, and reliable. Electrical and plumbing systems are essential components of modern buildings, and it is crucial to install them correctly to protect the health and safety of occupants. The use of field-installed cord caps on extension cords can present several potential hazards if not done correctly. Firstly, improper wiring connections. Field-installed cord caps require the installer to make the wiring connections between the cord conductors and the terminals within the cap. If these connections are not made properly, they can become loose over time, leading to arcing, overheating, and potential fire hazards. Secondly, incorrect wire gauge. Using the incorrect wire gauge for the cord or the cord cap can lead to overheating and potential fire hazards. The cord cap terminals must be compatible with the gauge of the cord conductors being used. Thirdly, inadequate strain relief. Cord caps typically have a strain relief mechanism that prevents the cord from being pulled out of the cap. If the strain relief is not properly installed or is inadequate, the cord can be pulled out, exposing the conductors and creating a shock hazard. Fourthly, improper grounding. If the cord is intended to provide a grounding path, it is crucial to ensure that the grounding conductor is properly connected to the grounding terminal within the cord cap. Failure to do so can compromise the grounding system and increase the risk of electrical shock. Fifthly, lack of listing or labeling. Field-installed cord caps may not be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, otherwise known as UL, or Electrical Testing Laboratories, otherwise known as ETL. This means that the cord cap has not been tested to meet established safety standards. To minimize the risks associated with field-installed cord caps, it is essential to follow these guidelines. Firstly, use only listed or labeled cord caps. Listed or labeled cord caps have been tested and found to meet established safety standards. Secondly, follow the manufacturer's instructions carefully. The manufacturer's instructions provide specific guidance on how to install the cord cap correctly. Thirdly, use the correct tools and techniques. Use the correct tools for stripping wires, tightening screws, and crimping connectors. Fourthly, inspect the cord cap regularly for damage. Replace any damaged cord caps immediately. Fifthly, if you are not familiar with electrical wiring, hire a qualified electrician to do the work. An electrician has the training and experience to safely install cord caps. When selecting a cord cap, choose a cord cap that is appropriate for the application. Consider the voltage, current, and environment in which the cord cap will be used. When installing a cord cap, follow the manufacturer's instructions. Use the correct tools and techniques. Do not over-tighten the screws or terminals. Inspect cord caps regularly for damage or wear. Replace any damaged or worn cord caps immediately. Do not use cord caps that are cracked, broken, or otherwise damaged. If you are not familiar with electrical wiring, it is best to hire a qualified electrician to do the work. An electrician has the training and experience to safely install cord caps.